Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this. I'll title it how I title it in the title. But what I am sure of are 4 goals for today. Our first goal is going to be to review the structure of a congruent triangle argument. Our second goal is going to be to define isosceles triangles and name their parts. Our third goal is to prove a property about an isosceles triangle and prove the converse. And our fourth goal is going to be to extend the result from the third goal to equilateral triangles. So let's just go ahead and jump right in. Our first goal is to review the congruent triangle argument. We determine if triangles are congruent using angle, side, angle, side, angle, side, 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 side. Let me fix this right now. Side, side, side. Angle, angle, side, or hypotenuse leg. We write a congruent statement and list the congruent corresponding parts. We use a congruent corresponding part or parts to reach a conclusion about the original figure. Again, this is our second argument technique that we're learning, and we're going to see it put in place today. We've seen it a little bit, but now we're going to see it in action. All right, so I can check off the first goal, right? Argue triangles are congruent. Write a congruent statement, use the congruent corresponding parts to reach a conclusion. All right, the second goal, which is to define isosceles triangles and name their parts. An isosceles triangle is a triangle that has at least 2 congruent sides. The congruent sides are called the legs. The angle created by the legs is the vertex angle. The remaining angles are the base angles. The side opposite the vertex angle is the base. I went through that a little bit fast, but I think it'll be okay. So what I have here is an example of an isosceles triangle, and I know that this is an isosceles triangle because these congruent marks tell me that I have at least 2 congruent sides. So triangle RST is isosceles. Okay, I know that. I know that I have at least 2 pairs of congruent sides that are the legs. So side RT and side ST are the legs. Exciting writing happening right now. So there are the legs. The third thing, the angle created by the legs is a vertex angle. So angle T is the vertex angle because it's created by the legs. So I'll write that down here. Angle T is the vertex angle. Because again, it's created by the legs. The fourth thing here, the remaining angles are the base angles, so that means angle R and angle S are the base angles. The terrible E. And the last thing, the side opposite the vertex angle is the base. So side RS is on the opposite side of the vertex angle, which is angle T, so that means that side RS is the base. Okay, so I can come over here and check off the second goal. I've defined the isosceles triangles and I've named their parts. We're going to need to understand that to move into the third goal. Let me go ahead, erase all this, set the next part up, and I will be back. I'm back. So let's go ahead and jump into our third goal, which is to prove a property about isosceles triangles and prove its converse. So we'll start off with the proving a property about the isosceles triangles. So here's the claim. Isosceles triangles have congruent base angles. We want to use the congruent triangle argument style to show that starting with an isosceles triangle or a triangle with at least 2 congruent sides creates congruent base angles. So again, we're going to start with something. We're going to argue that we get congruent triangles. We're going to write a congruent statement, list the corresponding congruent parts, and we'll reach a conclusion about our shape because we have congruent triangles. So we start with an isosceles triangle ABC, where side BA is congruent to side CA. We want to show that angle B and angle C are congruent. Those are the base angles. So I have a statement here. Why can't we use the congruent triangle argument right now? So why don't you hit pause, see if we can figure that out. Just take a second, hit pause and see if we can figure it out. Hopefully you hit pause and figured out why we can't use a congruent triangle argument. Well, it's because there's only one triangle. We only have one triangle. We're going to make two triangles, all right? And we're going to make it in a very specific way. Now, as I was thinking about this lesson and working through it in my mind, I realized I never went over the following construction with you guys. And so I'm going to ask that you just accept that this is a construction that works. But if I'm going to validate this construction works, I'm actually going to use the congruent triangle argument. So what I'm going to do is I'm going to bisect angle A using a compass, which for me is a piece of yarn, and a straight edge, which is a ruler, and I'm going to create two triangles. So I'm going to create two triangles by bisecting angle A. Not a very good C. And when I bisect angle A, I'm going to create a pair of congruent angles. So let me get my compass. I'm going to make an arc. And then once I make an arc, I'm going to come down. I'm going to make two marks out of the... Let me do that again so I can make sure this is right. There we go. And I connect my intersection of my red arcs to my point A, and I've actually bisected angle A, and I now have two triangles. Okay, I've bisected angle A and I have two triangles. Okay, now we have two triangles. Okay, so let me clean this up a little bit, and I do intend at some point to make a lesson showing you why this works. The angle bisector, but just for now, I'll be a used car salesman and just trust me. All right. So we know now. Well, let's name this point D. That's point D. So we want to argue that triangle BAD is congruent to triangle CAD. We want to now there's one bad triangle. Triangle BAD is congruent to triangle CAD. Okay. Now there are some congruences, right? For example, we know that we have congruent sides to start off with, but I also have congruent angles, and I know that angle BAD is congruent to angle CAD. And that's true because we bisected angle A, right? So angle BAD is congruent to angle CAD. And let me make better arcs to show that. So I got an arc that's congruent, and that's congruent because we bisected angle A. All right, now I also have a reflexive congruence, and I know that side AD is congruent to side AD. And see if you can determine why the two triangles are congruent. So why don't you hit pause and see if you can do that. Remember, reflexive means the same as itself. Okay, so I've argued that I have congruent, well, I haven't argued it quite yet. I'm going to now say that I have congruent triangles. So I can say now that triangle BAD is congruent to triangle CAD. And this is because of side, angle, side. And now I can list the congruent corresponding parts. I have a congruent statement, so I can list the congruent corresponding parts. So let's start with the angles. I know that angle B is congruent to angle D. I'm sorry, angle B is congruent to angle C. It's very important that we go, that they match up, right? So next to the side with no mark and one mark, next to the side with one mark and two marks, and then next to the side with one mark, no mark, I'm sorry, 2 marks, no mark, 2 marks, no mark. So they're corresponding, they're named correctly. And by the way, guess what? This is what we wanted. We wanted this. I don't need to list everything else. These are base angles. That was a terrible E. Okay. So, what we now know is that a triangle with 2 congruent sides becomes a triangle that has the 2 congruent sides and it has congruent base angles. We proved this. We proved it. So I proved the first part, or proved the property about a isosceles triangle. Now I want to come back and argue about the converse, which means we're going to start off with a triangle that has 2 congruent angles. Can I argue that that triangle has 2 congruent sides? So why don't you, well, you're going to hit pause anyway. Okay, why don't you hit pause, see if you can figure out the argument. I'm going to go ahead and clean this up, set up the second part of the third goal. I will be back. I'm back. So now I want to go ahead and argue the converse of what I just argued. So prior, I started with an isosceles triangle. And I proved that the base angles must be congruent. Or a triangle with 2 congruent sides means that there's 2 congruent angles, which are the base angles. This part of the third goal, I'm going to start with a triangle that has 2 congruent angles, and then I'm going to argue that the triangle has 2 congruent sides, which means it must be isosceles. So it would be a really good thing for you to hit pause and see if you can kind of map out the idea of an argument. I'll give you a second to try and figure that out. If not, just watch through and see if you can follow along. Hopefully it makes sense. So we're going to start here with triangle ABC, where angle B is congruent to angle C. And I'd like to argue that side BA is congruent to side CA, which makes the triangle isosceles. So hit pause if you want to try and do this argument on your own. Hopefully you do. Give it a shot. And I hope you did. All right, so if you did, I'm back. And I'm going to go ahead and, like before, I'm going to make 2 triangles by bisecting angle A. All right, we're going to work our way into the congruent triangle argument by building congruent triangles, and I seem to have hidden my compass for myself. I hid it over here. All right. So let me go ahead and bisect this angle. And again, just trust me, this does work. Okay. So I make an arc, come down, make an X, make them intersect. I now have 2 triangles. and I built two triangles that have some congruences in them by construction. I know for sure that I've built congruent angles. Okay, so we bisected angle A, and in bisecting angle A, we accomplished two things. We made two triangles, right? And we built congruences. So I know that angle, that's point B. I know that angle BAD is congruent to angle CAD because we bisected angle BAC. So I'll just write that out real quick. Angle BAD is congruent to angle CAD because we bisected angle A. Alright, I also know that side AD is congruent to side AD, and maybe these congruences are feeling a little familiar because you just saw them in the previous argument. I can go like that because they're reflexive. All right, now, I don't know if you can determine why my two triangles are congruent. Hopefully you see the pattern, but I can now state that I do have congruent triangles. There are congruent triangles. And I can say that triangle BAD is congruent to triangle CAD because of the angle, side, triangle, congruent triangle criteria. So, triangle BAD is congruent to triangle CAD because of angle, side. I have a congruent statement. So now I can list congruent corresponding parts. But let's just be a little bit more sophisticated with how we list it. We're interested in side length, so I don't need to list the angles. Right? So I don't need the angles, we'll just talk about the side. I can say that side BA is congruent to side CA. And guess what? This is what we wanted. We wanted this. So triangle ABC must be isosceles. Okay? Because that has two pairs of congruent sides. And we get that result because we started with two congruent angles. It was an ingredient for the cake. Right? So now we know that if we have a triangle that looks like this, I can say that my triangle must have congruent base angles. That was the first part of the third goal. The second part of the third goal that says if I have a triangle that's doing this, then I can say that my triangle must have congruent sides. So if you start with this, you get this. If you start with this, you get that. All right, so I'm going to go ahead and check off my third goal of the argument. Now, for the homework, maybe you have to use or set up equations. I'm boring. But those equations you can set up are a result of us using the congruent triangle argument style. Now, the fourth goal, I'm not going to go through all the arguments. I'm going to use this. This is going to help me achieve the fourth goal. And you're going to see a combination of our argument styles. We have a congruent triangle argument technique, which got us to this. And our other argument technique, which is transitive, you will see it be used to create a result about equilateral triangles. So let me clean this up and I will be back with the fourth goal. I'm back. So let's go ahead and jump into our fourth and final goal. This is going to take two sections to go over, but they're going to be pretty short. From what I can tell and I mapped out in my mind. All right, so the fourth goal is to extend the result from the third goal to equilateral triangles and equiangular triangles. I just added this. Make sure you add this to your goals, please. All right, an equilateral triangle is a triangle that has all congruent sides. And then here's an example. There's nothing there. But I want to show you that I can actually build an equilateral triangle. So if I put a dot there, take my compass, and put the needle on the point, and make an arc. Let's make this big. Yeah, I'll make it like that. And make an arc. Come over here, put a point right there. Anywhere actually works. But I'm just going to try and make it parallel to the ground. I don't know why, but I am on this one. Come over here, replace the needle on this point, put the pencil on the original point, and make an arc going in the other direction. I have just created 3 equal lengths. From here to here is the same as from here to here, and that's the same from there to there. This will be an equilateral triangle. It's built that way. It's built that way. So let me add this in, connect the dots. And this is a equilateral triangle. So I know by building it, this thing needs to have 3 congruent sides. This is an equilateral triangle by construction. Let me just erase the rest. You don't have to include the construction in your notes. I just wanted to show you that. So we'll label that A, we'll label that B, we'll label that C. And by construction, I know it's equilateral. Right? Now, remember from our third goal that if I have a triangle with 2 congruent sides, I get 2 congruent base angles. So, if we cover the congruent mark on side BC, that means I can say that angle B must be congruent to angle C. By the property of isosceles triangles, right? If we cover the congruent mark on side AC, that means I have this, but now angle C is congruent to angle A. Well, guess what we created? This is transitive. So, that means that angle B must be congruent to angle A. And if we start with an equilateral triangle, that means we get a triangle with 3 congruent angles. So a triangle with 3 congruent sides means that I get a triangle with 3 congruent angles. By the way, this triangle right here, this is what's called an equiangular triangle. Okay, so I've got one more part to this lesson. I'm going to prove the converse. I'm going to start off with an equiangular triangle and show how it turns into an equilateral triangle. The argument is pretty much the same. Again, I just ignored a congruent mark, realized I had this, so I got that. And now I'm using what I've argued and simplifying the arguments, right? So you don't have to create new triangles and go through the whole process again. And you know, I'm going to also talk a little bit about the, well, actually, I'll hold off on that. So let me clean all this up and I will be back. I'm back for the last time, I promise. So let's go ahead and finish the 4th goal, and we're going to start off with an equiangular triangle and see what that result leads us to. So an equiangular triangle is a triangle that has 3 congruent angles. So here's a triangle ABC that's equiangular because all 3 angles are congruent. And I just want to remind you of what we have from goal 3. If we start off with a triangle that has 2 congruent angles, then that triangle has 2 congruent sides. It must be isosceles. All right, so if we cover up the congruent mark on our angle A, that means that side BA must be congruent to side CA. I'll write that out. So if I cover this guy up, then I have exactly this, which means I get that, and side BA is congruent to side CA. Now, if we cover up the congruent arc on angle C, again, I'm going to have 2 congruent angles, which means that the length from B to C is the same as the length from C to A. Right? So again, covering this up, you see what I have that, it's just rotated 90 degrees in the, not 90 degrees, it's actually 60 degrees. No, it's 120 degrees. It's rotated 120 degrees in the clockwise direction, which means that this side must be congruent to that side. So we cover up a congruent arc on the angle C, we get that side BC is congruent to side CA. Well, guess what happens again? This is the transitive property. So, because 2 things are congruent to the same thing, those 2 things themselves must be congruent. So that means that the length of, or that side BA must be congruent to side BC. We have 3 congruent sides. So, if we start off with a triangle that has 3 congruent sides, we get a triangle that has 3 congruent angles. I want to make sure I'm on the screen. I have a feeling I'm falling off the screen. Oh, I'm just barely on. Okay. That's not very well drawn, I apologize. Or if I have a triangle that has 3 congruent angles, I now have a triangle that has 3 congruent sides. So equiangular triangles are equilateral triangles, and equilateral triangles are equiangular triangles. which means these triangles are what we call regular. Okay. Regular shapes all sides are congruent. All angles congruent. Now, guess what you can figure out about any equal angular triangle? If all three angles are the same, and they all add up to 180, you can figure out what each angle adds up, what each angle must be. And I'm not going to tell you. I'm going to leave that one up to you. Okie dokie. Whew! Long lesson. My brain is tired. Okay, so again, hopefully you saw and understood how I use the congruent triangle argument. Understand what it means to be an isosceles triangle. By the way, at least two congruent sides. Equilateral triangles are isosceles. We know how to name their parts. We proved the property about isosceles and its converse, and we extended the result to equiangular and equilateral triangles. All right. So again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.